This video is for Homework and Mastery 3.6, Section 12.3 in your textbook. Fundamental operations on polynomials. What we're going to do here is look at polynomials, being able to recognize them, we'll add and subtract them, and also get into some other operations as well. A polynomial in X is the sum of a finite number of terms of the form a(xn), where a is any real number and n is a whole number. What this means is a polynomial, it first of all is just having the same variable throughout. We combine it and simplify it down to where we have combined all like terms, and we have a possible coefficient like 5 or 1 in the front of our variable. This polynomial is in terms of c because we have the variable c. A multivariable polynomial is where we have more than one variable, such as y, z, and w, or if we had x and y. Here we have a and b. It just means that we have more than one variable, more than one letter. We want to look at the degrees of terms in a polynomial. The degree of a polynomial, or the degree of a term, is the sum of the exponents for the variable, meaning the sum of the exponents in the variable of that term. For example, 5x squared has a degree of 2 because the exponent is 2. 2c to the third plus 5.1, we still have an exponent of 3, and that is our largest exponent. Therefore, that is the degree of the polynomial. The degree of the polynomial is the highest of all the terms in the polynomial. So if we look at 4y to the third, z to the fifth, plus 7y squared plus 6, the 6 has a degree of 0 because it does not have a variable at all. 7w squared has a degree of 2 because of the w squared. Here we have y to the third, z to the fifth. We add their exponents and get 8. So the degree of this term is 8. So we have a degree of 8, 2, or 0. Well, 8 is the largest degree of any term in this polynomial. Therefore, the degree of the polynomial is 8. This would be an 8th degree polynomial. Here, with 2a to the third plus b squared minus ab, we add the exponents 1 plus 1. This has a degree of 2. B squared also has a degree of 2. 2a to the third has a degree of 3. Therefore, the degree of this polynomial is 3 because a to the third has the largest degree. There are different types of polynomials. A monomial just has one term, 5x squared. That is a monomial. It just has one term. A is considered a monomial. 2c to the fifth d is a monomial. Binomial has two terms. We have two different things added together, and they are already simplified to where we've combined all like terms, and we still leave two terms. So this is a binomial. 5x squared plus 3, or ab minus 4. Notice our terms are separated by addition or subtraction signs. A trinomial has three terms, tri meaning 3. So we have 5x squared plus x minus 3, 3 terms. ab minus a plus b has 3 terms, so this is a trinomial. Anything larger than 3 terms is just called a polynomial, meaning multiple terms. When we want to add polynomials together, what we want to do is we want to combine like terms. Just because they're in parentheses, we want to first determine if there are any like terms within the parentheses that we can simplify, and then we will add the two polynomials. Whenever I add the polynomials, again, I'm going to add their like terms. Like terms mean that they have to have the same variable with the same degree. So the 5x squared and the 2x squared are like terms. The 6 and the negative 3 are like terms because they do not contain a variable. The negative x does not have any like terms, therefore it will stay the same. What I have done here is I have rewritten and simplified a little bit to where I have gotten the like terms together. I have set the 5x squared plus 2x squared next to each other, plus the negative x, plus the 6 plus a negative 3, because the 6 and the negative 3 are like terms. I will now simplify by combining my like terms. 5x squared plus 2x squared will give me 7x squared, plus a negative x, plus 3. Instead of saying plus a negative x, that is going to be the same thing as 7x squared minus x. Where we're writing our polynomials for our final answers, we always want to write them in decreasing order. What that means is the exponents need to step down. Our degrees need to be decreasing. So x squared, x to the first, and then our constant, our term without a variable. So this is what we're going to be looking at here. Let's look at another example. I have 1/2 x squared minus 6x plus 1/3 plus the polynomial 1/5 x squared minus 2x minus 1/2. Again, I want to combine my like terms, and so I'm going to look at the x squareds together, the x's together, and then the terms without x's, such as here. I have 1/2 x squared plus 1/5 x squared plus a negative 6x times, that should say plus a negative 2x, and then I should have a plus sign here, 1/3 plus a negative 1/2. Remember, when combining fractions, you must find a common denominator. So for my x squareds, my common denominator will be 10, between 2 and 5. Multiply the 2 times the 5, I have to also multiply the numerator by 5, and I get 5/10. 5 times 2 to get 10, so I have to multiply the 1 times 2 as well, and I get 2. The negative 6x and the negative 2, I can just combine those into negative 8x. Whenever I want to add 1/3 plus a negative 1/2, I must also get a common denominator, and my common denominator will be 6. 3 times 2 will give me 6, so I must multiply the 1 by 2 also, and get 2/6. 2 times 3 is 6, so I must also multiply the numerator 1 by 3, and I get 3/6. Now I can add or subtract my fractions as necessary. 5/10 plus 2/10 gives me 7/10 x squared, plus a negative 8x. 2/6 minus 3/6 gives me a negative 1/6. Notice I already have this written in descending order, or decreasing order. I have x squared, an x, and then my constant. Let's look at this one. This has 12x to the third minus 5x squared plus 5, plus the polynomial negative 3.4 x to the third minus 1.2 x squared plus 4.5 x minus 7. Again, I want to combine my like terms, which are the ones that have the same variable to the same degree. So I'm going to combine my 1.2x to the third with my negative 3.4x to the third. I'll combine my x squareds. My x does not have another common term, so I'll leave my x squared. And then I'll combine my coefficients, or my constants. 1.2 minus 3.4 will give me a negative 2.2 x to the third. Negative 5.6 minus 1.2 gives me a negative 6.8 x squared, plus my 4.5x, and then 5 minus 7 gives me a negative 2. Again, these are in decreasing order for my exponents. When I want to subtract polynomials, I have to first look inside my parentheses to make sure that I cannot combine any like terms. Simplify inside my parentheses. Once I have simplified inside my parentheses, I need to distribute my negative sign. Think of this as a -1, and I'm going to distribute it into my negative sign, which makes all my signs inside my second parentheses change. So my first parenthesis stays the same, 3a to the fourth plus 5a minus 6, and then I will have plus a negative 2a to the fourth minus 2a plus 3, because I want their opposites. Now I can combine like terms just like I have been. I'm going to say 3a to the fourth minus 2a to the fourth, 5a minus 2a, and a -6 plus 3. 3a to the fourth minus 2a to the fourth will leave me with a to the fourth. 5a minus 2a will leave me with 3a, and a -6 plus 3 leaves me with a -3. So one thing that we must remember is that when we want to subtract polynomials, we have to, if there are parentheses already involved, we must distribute our negative sign. If we want to evaluate a polynomial, which we want to do many times to predict values, we want to replace our unknown variable, such as our x or y, with the value that we are looking at. So automobiles sold in the United States have become more fuel efficient over the years due to regulations from Congress. The number of moles per gallon obtained by the average automobile in the United States can be described by the polynomial 3/10 x plus 12 and 9/10, where x is the number of years since 1970. Use this polynomial to estimate the number of miles per gallon obtained by the average automobile in 1972. Here we have to think of two different things. Since x is the number of years since 1970, and I want to look at 1972, I'm actually going to be looking at x equaling 2, because that's 2 years after 1970. Once I figure out what x is, I will replace my x inside my polynomial with my x of 2. I get 3/10 times 2 plus 12 and 9/10. 3/10 times 2 gives me 6/10 plus 12 and 9/10. 6/10 plus 12 and 9/10 gives me 13 and 5/10. So we're going to estimate that the average car in 1972 obtained 13.5 miles per gallon. Again, this problem required two different operations. You first had to find out what your x was by determining the number of years since 1970 that we wanted to look at, and then plugging in that number in for our variable. One very important thing to remember when adding and subtracting polynomials is that you want to change the signs of your second polynomial if you are subtracting, and then just combine like terms. Again, always write your solutions in decreasing order for your exponents. If you need any help, let one of us know.